Hello and welcome to the fourth video of our groups tutorial video series. This time we want to focus on loops and conditions, and I'm going to show you how you can use them to make your script even more powerful and even more flexible. So we are using our script from the previous video where we visualized differences between kinematic and reduced dynamic orbits for certain satellites. And if we go back to our data, you can see that we have data for 3 satellites, GRACE 1, GRACE 2, and GRACE TerraSAR X. And we have data for 1 week for each satellite. So of course, we could run our script for each satellite and each day, but that's cumbersome. So it would be great if we could run our script once and it would plot the differences for each day and each satellite. Thankfully, we can do this using the loop feature in groups. So first of all, we want to loop over our day. So we'll add a new program called loop programs. And here we can define a loop. There are different options. You can use times, you can use a loop from a file, from a matrix, and so on. Now, in our case, we will use time intervals, and we will define our time period. So it starts in 2015 on the 1st of January and ends on the 2015 on the 8th of January. Here, since we're using time intervals, the endpoint of the interval has to be 1 past the last day, because intervals are always defined between 2 time points. And for sampling, we use 1, so we want daily sampling. And for convenience, we will set both time start and time end as global variables by right-clicking them. So we can change them in the global section. We don't have to go into this location to change them. Okay, what we do not need anymore is the time variable we used in the previous video, because this loop creates a new variable called loop time. We can use a different name, but let's stick with loop time. And in each iteration, this variable contains the current time stamp. For example, in the first iteration, it will be the 1st of January, then the 2nd of January, and so on. Okay, what we can also set here is if we want to continue after an error. So if any of the programs within this loop cause an exception, we can say, okay, just skip to the next iteration and continue going. So we'll set that to yes, and just to be sure. Okay, so this is our outer loop over the days, and we also want to add an inner loop over the satellites. In this case, we're going to use a manual list, so we can define a list of strings. This will be GRACE 1, GRACE 2, and stat X. And in this case, we'll call our variable satellite. We already have a global variable satellites, which we used in the previous video. We don't need that anymore because now our loop will define the variable satellite, and in the first iteration it will be GRACE 1, then GRACE 2, and then TerraSAR X. Again, we'll set continue after error to yes, because if there is no data on one day, for example, we still want to visualize the other days. Okay, so now we have our 2 loops. We have the outer loop over the days and the inner loop over our satellites. For convenience sake, we can set the whole loop, the inner loop global, and let's call it loop satellite. So now in our global section, I can easily change the list of satellites. I can add some or disable some. So it's just for convenience. Okay, and now we have to move our programs into the loop. We can just copy or move them one by one. Actually, for the create directories, we will keep creating the plot directory outside of the loop, because we only want to create this directory once, but temp directory we will create in each loop. More on that in a second. Okay, let's continue pasting or moving our programs. Okay, so now I've moved all the programs we had on the outside before into the inner loop. So all of these programs will be run for each satellite in each day. as I said, or what we should now consider is that we might use different temp directories for each loop, just to be safe, so that we do not use any other file or any previous files from previous iterations accidentally. So what we can do is we can say, okay, we want to replace it's Control F to go to find and replace. We want to replace all occurrences of temp with a global variable temp here. Let's replace all. And with that button, you can close all programs again. And if we now add a global variable temp here from type file name, we can define a temp directory we want to use for each iteration. And let's use satellite underscore time with date. So for each, if we now go to file create directories, it will create a temp directory with in the subdirectory temp with name of satellite underscore and the date parsed as an ISO date string, which is convenient because then each day in satellite will have their own temp directory and that there can be no confusion with the data. Okay, so far so good. One thing we still have to change is, if you remember, we used our variable time beforehand, and here, for example, and now, of course, we don't want to use time, but instead our loop variable loop time. So we're gonna replace that, and now we should be able to run this script. And as you can see, it runs. If you go to our directory and go into the plot directory, you can see, okay, there's Grace 1 plot, Grace 2 plot, now the Grace X plot, and then for the second day, the Grace plot, and so on. So the program will continue running. It will take some time, of course, because we are creating quite a few plots. So let's delete them for now, because now I can show you another feature, which is we can parallelize our script, so we can run our script in parallel. So far we ran it with a single processor, but if we have tasks that can be run on multiple cores in parallel, then this can be quite useful. In this case, it's pretty easy. Let's just say we want to parallelize our time loop, so we want to plot multiple times at the same time. And this is very simple because we can here adjust in the outer loop the process count per iteration from 0 to 1. 0 means all processes are used for each iteration. So all the programs use all processes. In this case, this doesn't make much sense because none of these programs can benefit from more than one process. But if we change this to 1 in this loop, only one process will be used for each iteration in this loop, so for each day. And if we now run our script not with the single process executable, but instead with the MPI executable, if you have installed both if you have installed MPI, you can compile a multi-core or multi-process executable, and we can run this instead. And if you run this, we'll see, okay, multiple processes are working at the same time, and you can see multiple plots, or all 3 plots are generated at the same time. So it goes quite a bit faster. What we can also do is, if you think this is useful for your script, we can write log files. We could write a log file if we check this here. Then it writes all the output into this log file. But another thing we could do is add a program called group programs. And if we move our inner loop into this program and define an output file log for this group, which we could say should be in the directory log and should be of should use the date as a file name. We have to be careful, we have to create our log directory at the beginning. But now what happens is that for each loop, for each outer loop, for each day, it creates a log file where the output from this inner loop is written to. So if I run this again with MPI, again, everything happens in parallel, but now we have our log directory and we have one file per day. And this file contains the log output of the inner loop. So the conversion or the processing of the 3 satellites. And one more thing I want to show you is we can also add a condition. For example, if you remember, we said in our script that we want to visualize outliers by black diamonds in the plot. And we could now say, okay, we only want this to happen for gray satellites. Now, so if I right-click this layer for the diamonds and say set condition, I can define a new condition. Let's call it condition is grays. And for this condition, there are multiple types you can use. You can check files, you can run a command, and so on. But also you can match strings and patterns. So I'll choose here string contains pattern. The string you check will be the content of our satellite variable, and the pattern will be grays. So if grays is contained in the string, the condition will be true. And we have set this on this layer. So if we now run this and check our plots, we should see in the grays plot there still are the black diamonds for our outlier, but if I go to a teraSAR plot, you can see there are no more outliers here. So this is one way to use a condition. I want to show you another way or an alternative for both conditions and loops, because as you can see for loops, I used the program loop program, and for conditions, I right-clicked and added it. You can also do the reverse. So let's disable this program for now and add a new program called, again, let's use loop programs. This time we will loop over our satellites, and here we now are going to use the program if program. So it's just an alternative way of using conditions. So we will use our condition is grays in this case, and in this program, just to show you what I want to do, I'm going to use the program instrument concatenate, which, as the name says, concatenates instrument files. And I can just quickly show you that I can, for example, concatenate the orbit files, the original orbit files. Let's use some output file. But what I can do now is here, you can see I have one input file, but this element contains the ellipses, which means you can provide multiple files. You could now copy and paste it and change the date, but you can also set a loop on this element. Beforehand, we have to go back to our previous loop where we defined the loop over the intervals. We can set that global. Let's call it loop intervals. So now we can use this loop here. We can say set loop intervals. And now this config element will be duplicated for each entry in this loop. So in this case, for the 4 days. And if I now run this program, let's use the default one. You can see that it is run twice, because we have the condition that it's only run for gray satellites, grays 1 and 2, and then the program instrument concatenate, it reads all the 7 files and concatenates them. Okay, so this is the basics of our loops and conditions. Of course, this is a very powerful feature, so you can do quite a lot of things and complex behavior in your script. Yeah, so that's it for now. Thanks for watching, and bye-bye.